Well, good morning and welcome. This is the third in a series of 5 educational webinars that will be held this fall. Today's subject is glass recycling and addresses one of the quote problem childs unquote of the waste stream that the industry and municipalities and regulators deal with on a day-to-day basis. We'll get more into the subject of glass in just a few minutes. First, I want to tell you a little bit about Evan Liblit and the Evan R. Liblit Memorial Scholarship Fund at Stony Brook. In terms of Evan Liblit, the person, we remember Evan as an innovator and a teacher in the field of recycling and waste management. But Evan was definitely a student as well. He was always anxious to explore new technologies and techniques. He quickly learned and understood that the field of recycling was subject to a number of fiscal pressures, legislative compromise, and also the public's willingness to cooperate. And today, students of environmental management face similar challenges and changes when they examine today's modern management of solid waste. After Evan's untimely passing, the Stony Brook University recognized his contributions to solid waste and established a memorial scholarship in his name. The Evan R. Liblit Memorial Fund supports graduate students and undergraduate students, and the fund is ongoing and becoming self-sustaining and will benefit students for many years to come. We really do appreciate you remembering Evan, and we're honored to conduct these webinar series in his memory. Today we're going to be talking about glass recycling and how do we advance glass recycling here on Long Island, and we'll probably also talk about how do we do that throughout New York State as well. But I do want to talk about glass because it's such an incredibly excellent packaging material. We use it every single day. We know that glass, in addition to being a great packaging product, is also a material that can be and should be recycled. So that's the premise that we start off with. But we also realize that in addition to all of the good things that glass has, there's some other components that we need to think about as well. So on the good side, we know that glass is definitely the trusted, proven packaging product in terms of taste, in terms of the environment. The benefits that are associated with glass packaging are many. As we said, it's a great packaging product. There's no change to taste to the products that are packaged in glass. And again, very importantly, once glass containers are used, they can be recycled, resulting in significant environmental benefits. On the bad side is breakage. That creates safety concerns to workers in collection vehicles, safety concerns for workers at recycling facilities. And on the bad side, there's also a lack of sufficient markets for recycled glass. And then there's quality issues due to contamination. And then there's the ugly side of glass, and that is that glass does have an impact on recycling equipment. It is extremely abrasive and does cause the wear and tear of facilities, and it certainly does drive up processing costs as well. So what we need to do is take a look at and have a discussion about how do we fix recycling in New York? How do we improve glass recycling rates? How can we promote reliable markets here within the state and specifically here on Long Island? And how do we protect the investment that processors have made in the recycling infrastructure? And also talk a little bit about some of the challenges we face in terms of dealing with glass, because we do also have a bottle bill here in New York State. We have some excellent speakers today. They are truly experts in the field of recycling, not just recycling, but solid waste management. Leading us off today is going to be Anthony Kaur, the president of Omni Recycling. In addition to being a good friend, Anthony is a well-respected and longtime recycler here on Long Island. He and his family have been doing this for perhaps the past 80 years here on Long Island. He is largely responsible for working with many municipalities to establish and actually to start up recycling programs here on Long Island, and understands firsthand the challenges that both municipalities and processors face. Karen Densing is the president of Environmental Resource Recycling. She is an outstanding recycler and operator, runs a phenomenal facility here on Long Island to process bottle bill glass. The Environmental Resource Recycling is a division of Claire Rose, which of course is one of the largest distributor of beverages on all of Long Island. It's certainly the largest distributor of beverages on Long Island, but Karen runs a phenomenal facility. She's been with Claire Rose for the past 14 years, the past 5 years serving as the president of the recycling operations. Terry Liebeck, I think everybody knows Terry with the Department of Environmental Conservation. She is widely seen as the go-to person whenever you have a question or an issue or you need some guidance. Everybody seems to gravitate towards Terry, and I'm glad she's on the panel today. And she'll be introducing Gabby Gasted. Gabby is a professor at Alfred University and is just doing some amazing, developing some amazing programs for the future management of glass here on Long Island. So with that, we're going to, I'm going to stop the share so that we can go to speaker view. And our first speaker is going to be Anthony Corr, who's going to talk a little bit about setting the stage for how glass is managed today, and also some of the challenges and opportunities for municipalities and glass processors. Anthony, good morning.
Good morning, Will. Will, thank you for that very generous introduction. For those that don't know me, my name is Anthony Corr. Will is correct. It's been almost a century of solid waste management and recycling that my family has participated in. Quite frankly, the oldest family-owned business doing solid waste management in the country. Omni Recycling is only just shy of 4 decades old. But Omni Recycling was the inventor of glass bottle and can curbside collection programming in the US, starting with the town of Hempstead. But let's just talk about, Will, for a minute, glass. Glass was invented, man-made glass was invented in 3500 BC, 3,500 years before Christ. First man-made glass in Egypt, Mesopotamia. So when you talk about the product, you talk about what we're trying to do with the product, you also have to look at that history. Let me just look at the clock to make sure I don't go over. Because if we're going to talk about 5,000 years of glass, it's going to take more than 10 minutes, so we won't. But as Will mentioned, and Will, your presentation was very thought out, was very thorough and very detailed, and I'm going to jump off from there. Glass is an old packaging medium. It's been used for this long. It has always been very shocking to me that we haven't really recycled it well in the past 50 years. And let's talk about that for a minute. And let's talk frankly about how we're getting it, how we could get it, and where it could go. For everyone's information, probably I've spent over $1 million in R&D just in glass recycling in the past 3 decades. We still are putting money today into R&D for glass recycling. But ultimately, everyone has to realize that probably the one ugly truth about glass that Will didn't put on the ugly truth about glass is glass doesn't play nice with others. And that's our biggest problem. If glass played well with other recyclables, we could manage it better. But glass is one of those items where you have to keep it far and away from everything else. And every time we try to include it, it always messes up the works. If we include it in the recycling fiber, it's caused massive rejections and harm to the pulping plants and the mills. If we include it in the bottle and cans, it still gets embedded in the plastic and contaminates. When we introduce it into the plants, it just accelerates wear and tear on the iron components, on the steel, on the plastic finger screens, etc., on the baling machines, on the operations. So let's talk about, if we know the truth about glass, right? And we know how we are collecting it today, and we really have a vision for the future of where we can put it and what we can use as an application. Maybe we can put this all together. First, curbside residential programs are probably our leading source of incoming recyclable glass. And when I say recyclable, understand this. I am one of those, someone had used the word zealot in recycling. I am a zealot about recycling. And I'm probably one of the few industrial zealots that put money where his mouth is with regard to recycling and that desire. However, realize that I've always said publicly that when it comes to glass, we need more governmental intervention with it. We need more governmental regulation to force the using of it than we currently have. We collect it curbside. We collect it in drop-off bins where they tried to modify their curbside programs to eliminate it in the collection, and we have bottle redemption and redemption programs. What I found over the years in the history of glass, and you guys have all probably heard me before, when we invented the program of curbside in 1987, glass was not on the hit parade. We knew that everyone instinctively knows glass is a really good medium. It's one of those things that we don't have to worry about it degrading in the weather or the rain. We don't have to worry about it leaching and contaminating long term. We don't have to, that's why it's a great food product, because it doesn't hurt us. We all know that. And the fact that we haven't found a place for glass is beyond me, but maybe working together we can. But the first order of business is the fact that not only doesn't glass play well with other recyclables, colored glass does not play well with each other. So brown glass doesn't play well with green glass, and green glass and brown don't play well with clear. So then it comes to the thought, well, why don't we just regulate that everything sold in America is sold in clear glass? And if you want to change the product labeling or the marketing, you do that with a label that's approved, and everything could be clear glass. If we were bold enough to do that, and Anheuser-Busch and the beer manufacturers in Europe don't assassinate all of us, maybe we might be one step further to being able to really unify glass recycling. As it stands now, I'm a proponent of the best way to recycle glass is the redemption way, where people are coming up for a redemption, even if it was 25 cents, to get back that money on a clear bottle, a colored bottle, a brown bottle, a green bottle. And we could keep it all very separate. We kept it separate, we could possibly have a chance of recycling. Realize that it's not just the glass that doesn't play well with each other, it's really the ceramic component to what people believe is recyclable. The ceramics will kill us in any glass program. That all being said, and there are more learned people on the seminar than I am. I gave you a quick overview of that history. We know we have an issue and a problem. We've been promoting glass in the construction aspect of America. Use it for a construction substitute, a pea gravel substitute for drainage, a retaining wall substitute to filtrate water out to prevent hydrostatic pressure. All of these things are being explored. We've R&D'd them. We're continuing to R&D them. But I'm going to make one other bold suggestion. The reason why years ago glass wasn't accepted back in manufacturing of glass was the look. That if colored glass was to infiltrate the clear glass, obviously the product didn't look very homogeneous. So the product looked bad, right? Or it didn't look perfect. It didn't look pristine. We'll use it as didn't look pristine. Well, maybe we have to get over that. Maybe we should be buying clear bottles that don't look pristine, not because they don't function well, not because in any way they're contaminating the contents, right? But they're not pristine because we've used recycled products. We should be proud to buy a bottle that wasn't pristine, okay? I'm proud of Snapple actually moving and going towards plastic, because I know plastic can be more readily recycled than the glass, but I'd love to go back to glass and being able to use the glass to be recycled. I'll give you one other insight. At Jamaica Ash, they just, because of the 3T MTA Long Island expansion, their dispatch offices had to be knocked down. Jamaica Ash went out and designed a state-of-the-art dispatch office for recycling and solid waste management and truck deployment. When I say state-of-the-art, computerized entries, tracking of trucks, a whole bunch of software and hardware that really would make a garbage man blush. But I think the one thing that Jamaica Ash is the most proud of is the fact that their floor, the finished floor in the office, is made from a concrete glass recycled product that has been buffed and sealed with epoxy. The interesting point is when you run your hand along the floor, the buffers that clean the top layer to shine the concrete couldn't cut into the glass. So the glass actually protrudes microscopically and makes that surface very skid resistant, very anti-skid, or very durable with regard to anti-slip. It's a wonderful use of the product, but we're only talking about, even if every concrete floor was done that way, maybe taking 1% of our glass. We still have to worry about the other 99%, which is what I want to leave you. Will, before I turn it over, I want to leave that with you, okay? I believe everything is recyclable. We can make no garbage. The problem is economically, that can't be done, okay? When my family started recycling 80, 90 years ago, it was because what people threw out had value. So when that garbage load was done, somebody walked over, usually was a facility worker, and started to pick out that metal from the garbage, because at the end of the day, he could bring it to a metal reclaimer or a metal scrapyard and sell it for $1, right? That's why we invented recycling, because there was an incentive economically to pull it out of the garbage and salvage it, right? We do that today with precious metals. In the e-waste, we do it with regular metal that aren't precious. We do it with plastics. We do it with wooden pallets and skids. We do it with all of that, but we've never, ever done it with glass. No one has ever walked through one of my recycling plants, and I have enough, and there's enough of people running around, that if glass was something they wanted, they sure as heck would have taken it. They haven't. So I'll leave you and I'll end with this. Maybe it's a combination of us being zealots. Maybe it's a combination of the R&D and construction or construction applications. Maybe it's getting a hold of our assemblywoman, assemblyman, and state senator to tell them that the bottle bill has to be revamped, or they've got to legislate the application of glass somewhere. But we almost have to make a decision. 5,500 years ago, they invented it. Well, they didn't have the advent of plastics. Either we're going to go 100% into plastics and abandon glass completely. And by the way, I've said that to people. When I go to the store, I buy beer in an aluminum can because I know I can recycle aluminum and I can recycle steel. I won't buy it in glass, even though I'm trying to recycle glass. Maybe we have to change the buying attitude of the general public. Maybe we have to do it legislatively. Maybe we can come up with better ideas scientifically through Stony Brook, through Alfred, through the universities. But that's our challenge today. We're fixing a 5,500-year-old problem. Okay, so I leave it to the rest of you to give me some insight and guidance. I have to tell you, I haven't succeeded. I failed more than I succeeded with glass. I will tell you that. I failed 100 times more than I've succeeded. I need help. I'm the first one to say, I need help. Help me, please. Will, back to you. And thank you for your generous comments.
Anthony, thank you. And you're going to stick around for some questions that'll be coming up from the audience in just a little bit. Again, if you do have a question, just type them into the chat box and we'll get to those questions at the end of our presentations. So Anthony talked about curbside recycling. He mentioned other ways that recycling takes place here on Long Island, especially of glass. And Karen Densing with Claire Rose is now going to talk about the process that she goes through to take that glass that we take back to the store, we place into a machine, we get our nickel back, and then what happens after that? Again, there's no magic solution. Nothing just disappears. She has to do something with it. So Karen, good afternoon to you, and thank you for joining us to tell us a little bit about the magic that Claire Rose does with all of the glass that gets returned.
I appreciate it. Thank you. Yes, like Will said, I work for Erie Recycling, which is a division of Claire Rose. And what Claire Rose is an Anheuser-Busch wholesaler here on Long Island. So we distribute the beer to Nassau and Suffolk County out on Long Island. And what I do is I am a sister company to them. And I go around and I pick up the recyclables from the grocery stores where you go and you put your bottle in a machine. And that's called a reverse revending machine. And I am a third-party pickup agent through Claire Rose for Tomer and Invipco. And I get the glass back along with the aluminum and plastic 2 different ways here at the recycling center. I get it back as a whole bottle from a beverage center, which is where you purchase your beer, you go back there to get your nickel back, and they box it up and they get it back to us when we go deliver their beer as a whole bottle. And I process it here. I have a trommel where we throw the glass right through. It crushes it automatically for us. And it goes right into our bunkers and we haul it away. And we give back the customer the nickel, and we also give them back a handling fee, which is 3.5 cents on top of that nickel. And what that does is for the beverage center that handles that bottle, puts it back in the case for our drivers to go pick it up. We give them that money back. And how I also get it back through the reverse vending machines is we have our equipment that go out, our tractors and our trailers, and we go to the beverage grocery store, and it's already processed through the machine. You put it in, it gets crushed automatically, goes into a bin. We go out, we pick up that bin. You're going to get your nickel back from the store. So that really doesn't have anything to do with me. I get the bin back with the glass already shred. Again, that goes right in our bunkers and it gets hauled away. So on the Claire Rose end, on the beverage centers, we only take back what we distribute. So I can't get back a Miller bottle, or I can't take back a Corona bottle. But on the grocery store end that goes through the reverse vending machines, I get what's called the share of market. So I get some of Pepsi, I get some of Coke, I get some of Manhattan beer, I get some of Boning, Nestle water. So just because I don't distribute anything other than a glass bottle on the Claire Rose end doesn't mean I'm just getting back glass. So we do get a mixture of everything, the aluminum, the Coke can, the Nestle water bottle, so on and so forth. And that's where I get my share is if I put 1 million cases in the market, I get 1 million cases back somehow over a course of 50 grocery stores. That's how that works. So our bottles are already crushed for the most part coming back off of those grocery store trailers, and the whole bottle will get crushed. We do not keep any whole bottles here because we don't want anybody picking through it in the middle of the night and double redeeming that somewhere else, back at another grocery store, back at another beverage center. Years ago, like Anthony had mentioned, we had lines upstairs that we did separate the glass by color, and that's how we crushed it by color. It was brown, it was green, it was clear, and you got paid based off of the color, and it got hauled away on a trailer. Became too much for the beverage centers. It became too much for separating it. So about 5 years ago, we turned over to buying our trommel, which is where the pallet of glass goes directly in there, similar to a cement mixer. Crushes that glass down, goes up on a belt, and it goes outside. But that, on the other hand, very costly. The belts get used, the belts get worn, the machine gets repaired. It's one or the other. Am I answering these questions as I go along, or are we waiting for them at the end?
No, you can answer that one.
Oh,
The question that just popped up was how many
Okay.
tons of glass does Claire Rose process?
Well, I process anywhere from 15 to 20 million pounds of glass a year. And that's coming both from the beverage centers itself and then the reverse vending machines at the grocery store. Last 2 years with the whole pandemic, a lot of stores shut machines down. They didn't want the folks touching them, the germs, whatnot. So last 2 years, I can't really base my numbers off of that. I can tell you it went down a little bit. Just starting to see it pick back up again. People are buying the beer. They're just not recycling it right now. So I know when the town, specifically the town of Brookhaven, a few years back, went from the double to the single stream, I was getting phone calls 3, 4, 5 times a day. Can I bring my glass to you? Can I bring my tomato sauce jar to you? I can't get rid of it. So that's not what we do here. I have to tell everybody every day. So that's pretty much what we do here on our end. So we have a big facility. We do process everything other than just the glass, the plastic, and the aluminum. But the glass, it is a problem. It is a problem. Years ago, we took it off of New York, out of New York to New Jersey. Stopped doing that once tolls and fuel became too high, and now we haul it into the city, and it gets sent down to a mill there.
All right, good. Karen, thank you so much. You also will stick around for some questions toward the end. We appreciate that. Again, think about that. All those nickels that we put aside eventually get refunded to people who do the refund. It's probably about 60% of glass that does in fact get refunded. The other 40% either goes into curbside or goes into the trash. So we want to try to increase the amount of material going back into redemption glass. And that's a great way for glass to avoid some of the problems that Anthony talked about, which was avoiding that contamination issue. So that's certainly one option. And I believe 2 years ago, there was a governor's initiative. It was part of the governor's budget package to increase the amount of the deposit on glass. However, that didn't go anywhere. So probably more to be seen on the legislative side. When it comes to the regulatory side, Terry Liebeck has been on the front edge of glass recycling and some of the issues that we've faced since 2018, when the recycling markets collapsed because of contamination issues. The industry responded in kind. Anthony's company, our company here, companies across Long Island, throughout New York State, did a phenomenal job reinvesting in their facilities to improve the quality. There was a big shift that moved from focus on quantity to quality recycling so that there could be some recycling. Keep in mind, in 2018 and into 2019, recycling was on life support. Fortunately, it has come back. It has come back strong, and we're seeing recycling numbers increase. We want to see that continue. But the DEC was on the cutting edge of trying to guide municipalities and help municipalities, help processors, help even glass manufacturers. And Terry was really the point person on that. And she is here today to talk a little bit about the DEC's program and the program that they've set up also with Alfred University. So Terry, I'll turn it over to you, and if you could then introduce Gabby as our final speaker today.
Absolutely, thank you, Will. Let me just get this started. Well, it's really great to be here. We are very excited, Gabby and I'll introduce Gabby towards the end of my presentation, to talk about what New York State is doing to seek higher end uses for glass. And I have to say, when I was putting this presentation together, it's been quite a bit over the last few years in particular. So let me recap a bit about where we started, and then we'll get into where we're headed. So, of course, everybody knows the effects of National Sword. In the summer of 2018, we were directed by Governor Cuomo at the time to hold a stakeholder meeting to find out what all the issues were with National Sword and how that was affecting markets, particularly in New York State. So that first meeting was 3 hours of angst and hand wringing, and it was all gloom and doom, right? Everybody was concerned, and rightly so. But we said at the end of that 3 hours, okay, where do we start as a state? And the two places that were identified was recycling education and recycling markets. So that is where we started right in October. So the first stakeholder meeting on recycling education was held at SUNY New Paltz, and that was the genesis of the Recycle Right New York campaign, which started in 2019 as a voluntary effort. And now it is with SUNY ESF. It's got its own website, and it's really grown, and it's a great program. In October 2018, later that month, we held a specific market stakeholder meeting in Syracuse at SUNY ESF. Again, it was 3 hours of all the different materials that were posing problems at the time, not just glass. But at the end of that 3 hours, where do we start? Please start with glass. So late into 2018, right after that, we set up 3 glass stakeholder meetings, and one of them was in Long Island. So why are we focusing on glass? I think Will and Anthony did a good job of covering this already. I mean, it's the heaviest portion of the waste stream, and how it's collected impacts the marketing down the road. It's really never been a high value commodity. It's always ridden on the coattails of other materials. In MRFs, we've known this for 10 years before National Sword. It beats up MRF equipment. Because there's a lot of moisture associated with glass containers. It easily picks up contamination along the way. And biobuilt glass is the low-hanging fruit. That is the glass that is the quality that's being sought after by processors. But it's not all gloom and doom there. There are advantages to it. It's a highly recyclable material. Gabby's going to get into the versatility of the ways that glass can be used. And the public pretty much believes and expects that their glass containers that they're putting in the recycling bins are going back into glass containers. So there's the expectation there that higher end uses will be happening. So as Will just mentioned, in early 2019, the governor proposed an RCA expansion. It's RCA's Returnable Container Act. That's pretty much how we say it at DEC. But that was for the expansion of soft drinks, and that, of course, was going to take more plastic and aluminum out of the waste stream. So municipalities were concerned about that because, again, as I said earlier, those are the materials that were really covering the costs for glass processing. So please, again, the ask was, please focus on glass. So that didn't pass, but DEC was tasked with looking into the feasibility of expanding for wine and spirits. So we contracted with the Pollution Prevention Institute out of the Rochester Institute of Technology. More meetings were held on this, and they spent the bulk of 2019 actually researching this, and pretty much came up with, 4,500 new businesses were going to be impacted by this directly, mostly small businesses, and an estimated cost of $40 million annually just to get into the Returnable Container Act program. So that spring also, we happened to host a glass meeting for municipal recycling officials at our headquarters at Stony Brook. And we got presenters from Pace Glass in New Jersey, a glass processing company that unfortunately now is no longer in business, and Urban Mining Northeast out of Connecticut. They do a pozzolan, a concrete additive process. And both of them also represented the Glass Recycling Foundation at this meeting. The GRF is it's a 501c3. It's partners with the Glass Recycling Coalition and also the Recycling Partnership to address supply chain gaps and fund projects. So it was a really productive meeting. There was a lot of give and take, but at the end of it, it really came down to that industry needs a reliable supplier of recycled glass. And so conversations were happening at the table on the potential to consolidate it on Long Island for this purpose. So one of the things I thought of when I was putting this presentation together for you guys is it seems to me like it's pretty much in line with what the Northeast Resource Recycling Association came up with. There's about 100 municipalities in 3 states here in the Northeast. And this group is a recycling marketing cooperative. So I'm not sure if anybody has spoken with Reagan Bissonette, who heads up that program, but if that's a conversation to be had down the road for kind of what was talked about at this meeting, that's something that I can help facilitate. So additional glass work. Late in 2019, we entered into those contracts with recycling MOUs with various SUNY schools, and I'll have more on that on the next slide. And then even though DOT was a partner with us in some of these glass meetings that we held, we had a meeting specifically for them, of course, the timing right before COVID hit, about using more glass in projects. Any of you that were at those glass stakeholder meetings know that DOT is pro glass. They would like to see more of it used too, and they particularly like the foam glass aggregate for some of the projects they've been working on. They talked about the Nassau Expressway project that had very good results. And I just found out that this Harbor Isle development in Hempstead, which was not a DOT project, I think a residential housing project, also used it for waterfront resiliency. It looks really promising. So that's all great, except that the glass that was coming from Aero Aggregates in Pennsylvania, and of course they're using Pennsylvania glass and some from the state of Delaware. So how do we get New York glass, into these applications? And then starting in March and through June of 2020, of course, we were in full swing with COVID. We went into pause in New York, and one of the things that we paused was returnable container act redemption. So stores did not have to redeem during that time. And we got calls directly from industry saying, look, this is a big supply chain disruption for us. We need the glass. When is this going to come back online? And of course, we just kept saying, well, there's still Murph glass out there. What about that Murph glass? Have you taken a look at that? And so talking about supply chain disruption, I'm hearing also that, now there's a shortage of wine bottles too. So if supply chain disruption isn't going to force that, I don't know what will, but these two aren't the first things, and they're probably not going to be the last. So a little bit about the agreements that we have with SUNY schools. What I have highlighted here in yellow has to do maybe not directly with glass, but there's some glass components. So really the only school not working on it is University at Buffalo. But Stony Brook, I know you're all very familiar with David Tondes' work and his crew. They're working on the statewide waste characterization study for us, which of course is, glass will be a component of that. SUNY ESF, they have probably the most comprehensive of all the tasks in all the schools. And recycling market development is in their wheelhouse. We just updated their MOU to include specifically glass. And they've established the New York State Center for Sustainable Materials Management. That's kind of the hub for all of this work that's being done. And I mentioned earlier, P2I has been a partner in glass research. They've been great, but they're really going to transition now that work over to Alfred and Gabby's group and what she's doing in the Center for Glass Innovation. So just want to kind of give you a big picture beyond the New York borders, sort of what's happening, and this plays into what was said earlier about, the possibility of legislation, right? So DEC works with the Northeast Recycling Council and the New England Waste Management Officials Association on particular initiatives. We are on, New York sits on NERC's glass committee, and they have drafted model legislation, again, 11 states, not just New York, but there's model legislation out now for minimum recycled content for glass food and beverage containers and fiberglass. So that public comment period is underway right now. It ends November 11th. And if you want to take a look at what that looks like, the draft is on NERC's main page, and there's a link to it. We also participate in a Bottle Bill States work group, all things with that program. I haven't heard of really any expansions on bottle bills in other states except for Connecticut, and I believe theirs has taken effect this month. It didn't expand to include more glass material, but they've updated it. They've gone from a 5-cent redemption fee up to 10, which is good. And they also included those nips, those small liquor bottles that you find at liquor stores and baskets, usually near the front of the counter. So the nips have a 5-cent deposit on them, and they have to be returned to liquor stores. That's a litter reduction initiative. And interestingly enough, the rest of their bill looks like their law looks like it's similar to what New York proposed in 2019 for more soft drink containers. Also, too, now with the new administration, EPA has come out with some new recycling initiatives that states get a chance to weigh in on. And so NUMOA is very helpful with convening all the states. We review the documents, materials, and we all sort of weigh in with that. And there's an official letter that comes on behalf of all of us from NUMOA. So it just gives it a lot more weight when a bunch of states are saying the same thing, and glass was identified as a problem. And so the last thing I just want to mention that this is more New York specific, but EPR for packaging, is another thing that's probably going to get more attention. I know a lot of you are aware there was a bill that was proposed last year, that legislative session that didn't get passed, but there's a lot of interest in this. And as far as legislative fixes for this thing, government intervention, EPR is something that's going to be looked at as well. So that is me, and I so appreciate the opportunity to be able to speak about this. Like I said, when I was trying to tie all this together, we've continued to try to do a lot of work and explore options for glass. And we're really just so very excited for the work that Gabby and her team are doing at SUNY Alfred. And with that, I'll introduce Dr. Gabrielle. She goes by Gabby Gasted with the New York State College of Ceramics at Alfred University.
Thank you so much. Let me just pull up my slides here real quick. Okay, great. Thank you so much, Terry, for that great introduction, and to Anthony and Karen and Will for doing such a great job of kind of presenting the scene and some of the struggles that are happening and what we can do. So just to start out with, I'm the Dean of Engineering at Alfred University. We have this really unique statutory unit that's a SUNY school as well, kind of like Cornell's vet school or other statutory programs that Cornell has. So even though we're SUNY, we're inside of a private university bubble. And I show this slide not just to do a little advertising. So if anybody has bright high school students interested in science and technology, especially on the materials side, send them my way. But also to really highlight the fact that we're a very unique place in terms of the degrees that we focus on, and our history in ceramics and glass, materials, mechanical is really a special place to do this kind of research. There's actually no other glass science focused programs like this. In fact, our glass science degree was established in 1932. So we've been in the glass space for a very long time. And what's really helped us, I think, a lot in this project is the connections that we have with thousands of graduates in the glass industry right now. So we have really strong partnerships in our Center for Glass Innovation to reach out. And as I said before, I think it was Anthony who highlighted sometimes the mixing of glass with these other materials, and ceramics is a problem. And we're a unique place that we have folks that specialize in each of those individual materials areas and can really help us think through some of these problems. So we recently had DEC visit us at Alfred University, and we presented some of the projects we're working on over an 8-hour day. So it'll be quite a challenge for me to cover all of that in a quick, 5-minute snippet. But just so folks are aware, we do have probably 14 different projects in the glass recycling space through this partnership with DEC, and they're sort of all along the life cycle of end-of-life glass. So I've just highlighted a few in each of the categories, but we have a lot of others ongoing as well. And particularly the ones I'm not going to cover at all are the ones in the modeling space. So looking at atomistic modeling of what's happening at the glass surface, looking at environmental impact assessment of different glass recycling pathways, and doing techno-economic assessment to understand if the technologies and processes that our faculty and students are developing are worth it from an economic perspective, because that's a clear issue in glass recycling. There's certainly plenty of technology that we could throw at this problem, but it's very, very expensive, right? So our overarching goal with all the research that we're doing is to make sure we're really looking at very value add, affordable solutions in this space. So one area is really looking at pre-melt separation and sorting. So, what can we do to improve on some of these sensor-based systems? And we have folks at Alfred that really specialize in characterization. So we have X-ray diffraction, optical sensors, infrared and near infrared. And the thing with this space is now a lot of this sensor technology, the cost of it has come down dramatically over the last 10 years. And then combined with that, computing has accelerated just astronomically over this time frame as well. So machine vision schemes that make use of machine learning algorithms combined with some of these now lower price sensor technologies, these are becoming more and more affordable. So figuring out what kinds of combinations make sense for our circumstances. So there's already some of this color-based sorting happening in the EU. What makes sense for us in MRFs here in New York State and the US specifically, because things are a little bit different. Along with that, we're trying to take advantage of properties of the glasses themselves to sort of help with those sorting technologies. So this is a classic one where you can separate lead containing glasses using UV or other types of excitation. So really kind of exploring some of these technologies. This is showing sort of under UV, lots of differences that you can see just from that color difference of all these glasses that have varying composition. So it's not just about sorting glasses with lead, which is obviously a really important one, but really any compositions of these. And again, this is where the machine learning and algorithms can be combined with these sensor and excitation type technologies to really do a lot of sorting. We know that we're not going to be the EU and be asking all of our consumers to do color sorting themselves. That's been successful in some places, but we know that in a lot of places, certainly where we are in Western New York, the cost of hauling and the inefficiency of trying to move already separated things is just not economically viable, and it's not environmentally viable either, because if it's a hauling cost, there's also an environmental cost to that hauling as well. So we know we're going to be getting single stream glasses into the MRFs in most of these locations. So we have to come up with some ways to do some of that sorting at the MRFs that's very inexpensive and fast and safe. And that's what those projects are focusing on. A big problem in the MRFs is the mixing of the glass, particularly with a lot of their plastic streams. So we actually have a project team of mechanical engineers and glass engineers that are looking at co-extrusion with plastic. So actually just letting them be mixed and looking at products that we can make from them just being mixed together and having a shredding and extrusion process together. So we have a team that has a prototype that they're currently working on to do this, and we're excited about the possibilities there. We're also sort of looking at the really terrible kinds of scraps that are coming out of MRFs. So instead of, we have these teams that are focusing on making cleaner, higher quality glass. And we have teams that are focused on saying, find something to do with this as is. Like, let's just go with the lowest quality stuff. Don't worry if it's all mixed together. What can we do with it? And so we're looking at ones that have a lot of organics mixed in, iron impurities from grinding, and then figuring out, what can we do to quote unquote clean these glasses in the melt phase, right? So this isn't, like a cleaning like we might have where we're washing it and getting rid of impurities, but we're letting everything just get all mixed together and then coming up with processing steps that sort of do some cleaning in the melt phase. And you can see some of the resulting glasses that we've been able to sort of remove the color and other issues from with just processing. And of course, a lot of that is called decoloring. So we're working on a lot of manipulating those impurities within those glass materials, looking at how the absorption changes, and then basically you can get a clearer glass from using some of these processing steps. We have another team that's focused on new products, and this is showing some of the microbead team. This is one of the teams that's taking the worst stuff that's coming out of the MRF. So it's got plastics mixed in, it's got organics and paper and labels and all kinds of stuff mixed together, and they're making products with that stream without cleaning or sorting it. And that one process is a microbead process, which is shown to be able to take advantage of some really cool aspects of the fluorescence that's already built into the glass. So we've actually been working with a company to make an asphalt that after it's in the sun all day, it can absorb light. And so then it will fluoresce when a car shines its light on it at night. And so we actually have a prototype on our campus that's being put down right now, biking and walking path. It's purple for Alfred. You can see our purple themes throughout in a lot of our glass work. But it's really interesting. We're gonna test it out, see how long the effects last, and have people running and driving on it to see how it does. Foam glass is another area that can really take some low quality glass and make new products from it. So we're really looking at thermal properties of this. So it's typically the glass powder, again, kind of the low quality stuff all mixed together, and then blowing agents. And then we can really kind of study the thermal decomposition effects of this to produce a lot of different kinds of foam glass that have a lot of different properties in them. But this is another area where it's absolutely a value add product that we're looking to produce. Some other folks mentioned the increase in landscaping from a lot of these. So we're exploring in partnership with a couple New York State companies producing different types of landscaping and agricultural products. That microbead group is actually looking at being able to seed fertilizer into the microbeads, and they can be spread out on fields. They release the fertilizer, and then the glass just kind of stays in the dirt. It's inert. It doesn't flow when there's heavy rains or things like that. So that product might really help with eutrophication problems that happen from having excess fertilizer running into wetlands and other bodies of water. So that's an area we're exploring. Having the glass products be some type of pozzolan in concrete and cement production is one we're also exploring. Some of the other speakers mentioned that. That's a really interesting problem because that industry would actually take every bit of glass that was available. In fact, they have such a high demand that they haven't explored using these waste glasses because they don't think there's enough for what they would actually want to produce. So those have been some really interesting talks to really understand what the quality level might be and the specifications that would match that source, because that's obviously a really high demand sector. So we're working with some of those companies to characterize what they're currently using, and then different types of different processing pathways for waste MRF glass to see if we can get a good match there. But that's another very promising area for us. This is more of sort of examples of those foam glasses. and how they're sort of non-sensitive to color, which is a positive aspect. So we have 2 faculty leading that effort as well. So like I said, we have a lot more projects, and I'm happy to get into technical details of any of those, but just wanted to cover at a very high level some of what we're doing, and be sure to leave a little bit of time for questions. So thank you.
Gabby, thanks so much, and I want to thank all of our speakers. We do have a little bit of time for questions, and the first one is going to go to Anthony to talk a little bit more about concrete and road construction projects. You've mentioned in the past that there are requirements for how to build roads, and it does say in the DOT specification that you may use recycled product. What's one of the things we'd have to do to increase the amount of locally available? Because all these things are great, but if they're not here on Long Island, we're not solving a problem here on Long Island.
Well, Will, that's a really good start. If you guys remember, there was a DEC seminar or informational event that I think we had at one of the water districts, and I went up to the board, and DOT was there, and I crossed out the word may, and I wrote the word shall, and I said that one word change from may to shall would get rid of our entire glass problem. And then some people from Rockland piped up and said, well, what if it's not all available? And then I put a comma and I wrote, if commercially available. I will say one thing. We have to be cognizant. No one in our personal lives would try to save $1 and spend $100. I don't go home to my wife and say, we're going to spend $100, honey, to save $10. She would look at me like I'm half crazy. We have to look at everything we do. And that's why, Gabby and Alfred is so important, and the research is so important, because what we have to do is get us to a point where we can balance those environmental oppositions. We can balance. I'm a big Dirty Murph fan because we only picked it up once. The carbon credits I saved in collection with men and trucks, I can eat up in the plant and net out to a benefit. We have to look at that net benefit. Going to you, Will. First of all, Brad Slover will sell you processed glass from the MRF all day long. We make about 25 tons a day. 516-333-5741, and then he's there to sell it to you. We have it available. Concrete, drainage, pea gravel substitute, behind drainage devices, perforated pipes, in retaining walls, behind retaining walls. I've been a big advocate of. When you put it, Gabby talked about it, when you put it in concrete, in the Jamaica dispatch office, we didn't use enough because my concrete guys were very squeamish about it. They didn't know what they were going to see when they ground. They were conservative. The next pad we pour for an indoor office, we're using 5 times more. And you're going to see you're going to see a floor that looks like terrazzo in New York City, honestly. It's those type of things. Well, I think we have the ability to do it. We just have to be bold enough to say we're going to try, and we have to call up Brad and buy it.
Right. Another example, Chris Andre from the town of Brookhaven recently did a drainage program out at the Brookhaven MRF, and actually used concrete rings that were constructed with a minimum content of glass. They worked perfectly. The installation was perfect, and it's functioning very well. So there's definitely some uses that are out there. Just a quick question about, we talked about how many tons of glass that Clare Rose receives annually, but a question that has to go to Karen is, how do you make sure you're not redeeming glass sold by another distributor? So how does Clare Rose make sure they're not redeeming glass, or do you redeem glass from others that was originally sold by other companies?
Well, it's not perfect, but our drivers, we have to give back when the bottle bill came into play. Clare Rose has to give back an empty case and a bag to the customer. If I get back 500 cases of glass from a beverage center, I have to give him back 500 boxes. So in a perfect world, the beverage center is supposed to use my Budweiser box to put the glass back in. Our drivers know to try to not pick up anything. Is it perfect? Are you going to get a Miller bottle mixed in with a Bud bottle? You sure are. I'm still going to crush it because it's not going back there. If it becomes a problem, which it has not in a long time, we have to contact the distributor and say, listen, you gave us back too much. We're going to send it back to you and you properly dispose of it. Everything that comes from the reverse vending machines are already crushed, and that, like I explained, I get a share of market just like everybody else who is a third-party pickup agent for Tomerin and BIPCO. So I will get a Miller bottle, I'll get a plastic bottle of water, and we don't distribute anything in plastic. So but we do spot check everything, you know, before it goes through the machine, what we can see, and then we do still do stuff by hand upstairs on our mezzanine. So
Great. Thank you. I do see that we are at the end of our time, and I do appreciate the expertise that was shared with everybody. This was a recorded session, and the recording is available. I'll ask Caitlin to put into the message board where they can get a copy of the presentation. I also just wanted to point out next week's webinar is going to be on electronic waste, followed by November 10th, a presentation on how do we deal with storm debris management, which is becoming more and more important here on Long Island. Again, thank you for joining us. I hope everyone has a great day and keep recycling. Thank you.
thank
Thank you.
you. Bye-bye.